We're now at step 4. We want to make a decision about the hypothesis test. Now we have the evidence in our model. We've done StatCrunch and we've determined that the p-value, that is this area of this shaded region, our probability value, is 0.012. Quite small. Also, our z, I mean, you could tell from this sketch that it was greater than 2, but now we know through StatCrunch, our z-stat, as they call it, they calculate it out officially for us, is equal to 2.26. So using a couple of the criteria we've talked about earlier in the semester, we tend to call things unusual once they were bigger than 2 standard deviations away, or if their probability was less than 0.05, otherwise known as 5%. So both of these things are pointing to that situation. So that brings us to a decision. Are we going to reject the null? Are we going to retain the null? Are we going to reject it or keep it? What do we think about the innocence or truth of our null hypothesis? Should we keep it or should we reject it? Well, seeing this very unusually high proportion of crashes that involve cell phone use, I'm inclined to reject the null hypothesis. We found an unusual finding, strong evidence if we were in a court of law against the null's innocence. So we have doubt here. We can quantify our doubt there. So this is beyond reasonable doubt, we might say. It's very low probability. And we can reject the null. Be a little dramatic here, which means that we will go with the alternative, but ultimately our decision is to reject the null hypothesis. Hang on in this video. I'm going to offer some more explanation, a little more cut and dry decision criteria of how to know when to reject the null or retain the null.
Here's some promised clarity with the step 4, our decision. So there's one thing we haven't really discussed in the problem thus far, and that's something called a significance level. Its symbol is alpha. This is a Greek letter. It's a little a in the Greek alphabet called alpha. So you can hear it referred to as significance level, or sometimes people just write this symbol, or sometimes they say the word alpha. They're all the same. So recall earlier in this semester we used a rule of thumb that said that probabilities less than 5% were considered unusual. Well, this value can certainly change. 5% sort of seems arbitrary. So in hypothesis testing, we decide on alpha at the beginning of the testing process. And it really depends on the field of study. Some of them choose 10%, others like 5%, and some want 1% as their alpha level, which is basically the point at which the probability is considered unusual. So I like to think in a more practical way as a significance level of being the threshold of unusual or rare, surprising, weird. You might be able to come up with a few other words, but it's sort of a level at which if our probability is less than the alpha given, we have observed an unusual finding. So the decision comes down to this criteria. If the p-value is less than or equal to alpha, we reject the null. If the p-value is greater than alpha, we retain the null. It's a simple decision criteria that we use in statistics. So if our probability value in our problem that comes up as a result of what our data produces is less than the given level of unusual, we reject. Otherwise, we retain. So it really does give us something to compare to, something to make a strict decision on whether to retain or reject. Now, remember in our problem, our p-value is 0.012. Now, that's certainly less than the alpha that was given at 0.05. Thus, we reject the null. We came to that conclusion without this criteria, just as the simple proximity of the data being so far away from the mean and creating such a small shaded area, our p-value. But this will certainly aid us in our future problems. Before we leave this completely, I'd like to leave you with a visual that might help you better understand this decision criteria. So this is just a general situation. We're testing a null hypothesis. So we have the bell curve here. Our null value is underneath the mean. And here is alpha. Alpha is the threshold, the probability threshold for which, if you look to the right, we'll reject the null. And if our data falls to the left, we retain the null. So let me show you a few situations. Suppose our data falls here. Our p-hat, we'll find later maybe a mean, x bar falls there. That means our p-value is the area shaded to the right of that. So we can see here that this shaded region is clearly bigger than the pink region that was originally there. So that means that we are going to retain the null because the p-value is greater than alpha. Now you can see that the data clearly fell in the retained region, but that's because its area is bigger than the pink area for alpha. Here's another situation. We have a bell curve, we have an alpha given. It's going to say anything to the right, we reject. If the data falls to the left, we retain the null hypothesis. So suppose the data falls over here to the right. That means we would reject the null hypothesis. Just put the little blue lines there to accentuate the p-value there. It's the blue shaded region, sort of striped region. And we can see that that is much smaller than the alpha. So we're rejecting the null because the p-value is less than alpha. So if our data falls out here, we're in the reject region, which means that the area of the striped blue is less than, smaller than, the area of the pink. Hopefully that helps. It helps me to visualize things. Watch this a few times and see if you can kind of get to grasp this better.